Hello everyone, I hope everyone is doing well. This is Iftikhar Ahmed, lecturer in mechanical engineering at Bahrain Polytechnic. First of all, I would like to thank the American University of Ras Al Khaimah for providing this opportunity to showcase our work in their esteemed conference. The title of my presentation is Experimental Investigation for the Performance Improvement of Solar Cell Using Phase Change Material. Starting with the introduction, we know that the world is a big place and it's a home for 8 billion people. Recently we saw that we have crossed the 8 billion number. And we also know that in the coming 2 decades, or you can say less than 2 decades, 1 more billions are coming to join this party. Now to keep this party going, we need a huge amount of energy. Currently we are producing 170 million gigawatt to fulfill our requirement. But still, there are 1.2 billion people with no or little electricity. We need 47 million gigawatt more to fulfill the requirement. Currently, 80% of the energy that we are using is coming from the fossil fuel, and 20% is coming from the renewables like solar, wind, geothermal, nuclear, and hydro. The fossil fuel that we are producing are causing problems to the world. Problems like global climate change, global warming, and the main culprit here is the CO2 emission that is coming from the fossil fuel. We are expecting hydro, solar, and wind to play an important role to mitigate these problems and fulfill the energy requirement of the world. Now, solar energy is most abundantly available renewable resource for the power generation and is becoming more and more popular to tackle the pollution and non-sustainability of common energy sources. Various types of solar cells like amorphous, monocrystalline, polycrystalline, thin film, dye-synthesized and organic solar cells are currently used to convert solar energy into electrical energy. The efficiency of these commercially available solar cell ranges from 8.8 to 28%. And this efficiency decreases further with the increase in temperature of the solar cell. So what we can do? This efficiency can further be improved by incorporating an effective technique including alteration in the cell's architecture, the materials of the cell, and the cooling technique that we can use to cool down the solar cell and increase the efficiency. For cooling, various techniques like passive cooling, active cooling are used, and people have tried to reduce the temperature of the cell and increase the efficiency of the cell. From the literature, it has been verified that up to 5% of the power enhancement can be achieved by using an appropriate cooling mechanism. So if we cool the solar cell properly, we can enhance the power output of the solar cell. Initial assessment has been done in this research to study the performance improvement of solar cell using phase change material based cooling technique. We have used a phase change material which changes its phase upon the temperature, and it will absorb the heat from the cell. On the next slide I will show you, and this technique we have used to cool down the solar cell and increase its efficiency. Now what we have done, you see here the cross-sectional view of the mechanism, or you can say the setup that we have done. We have an aluminum container. In that container we have filled the container with the phase change material, and we have used the paraffin wax like normal candle wax as a phase change material. On the top of that we have put the solar cell. Now you can see in the red yellow the heat is coming from the, let's say, the solar irradiance is coming to the solar cell, and then it is passing from the solar cell going to the phase change material. It will absorb the heat, and at the end we have fins which will just blow away the heat to convection. So this phase change material will absorb the heat from the solar cell, which will cool down the solar cell, and the phase change material will melt. So throughout the day the phase change material will absorb heat and it will become like liquid, and in the night it will become solid again, and then the next morning this process will be continued. So without using any energy we can cool down the solar cell. The solar cell that we have used, here are the parameters of the solar cell, you can see, and this mechanism how we have developed. You see here in this figure, the first figure A, we have the SolidWorks model of the cavity that we have made from the aluminum. The other side is the side view where we can see the fins that we have made at the back side of the cavity. Below in figure C, you can see the cavity that have been manufactured, the top view, where we will fill this cavity from the phase change material. And in figure D, you can see it is the backside view where we can see the fence. In figure E, we have filled the cavity with the phase change material with the wax. Now it is completely filled with the wax, and then in the last figure we have put the solar cell on it. We have used monocrystalline solar cell, we have used properly on it. So this is actually, with the normal solar panel, you might have seen that white material at the back of the cell. Here we don't have that white material, and we have our own new setup, which will have this phase change material and the aluminum container, which conduct heat further, and the heat is going away at the back side through the fan. So this is the new setup that we are proposing. Now we have done some experiment. We have used two solar cells, one with our setup where we are using the phase change material, and the next one without the phase change material. We have used a solar simulator where we can provide different types of solar parameter, like solar irradiance is there. We can change it, whatever we want, we can provide it there. We measure the temperature with IR sensor, and we are measuring the voltages of both the solar cell using digital multimeter. In this setup, we can change the angle, the tilt angle of the solar cell, and we can increase and decrease the intensity, which of course it will change the irradiance. We have used the irradiance of Bahrain, and whatever irradiance was on 1st June 2022, we have simulated the same thing in the laboratory. And you can see here from morning to evening, the irradiance values that we have, like from 6 watt per meter square, it is reaching to almost 950 watt per meter square, and then it is going down in the evening. We have replicated the same scenario in the lab, and we have recorded the data. In the result, you see, first what we have done, we have measured the temperature with time. So as you see here, we have the temperature of the solar cell with phase change material, and we have the temperature of the solar cell without phase change material. And you can see clearly, it can be seen from the figure that the one which has phase change material has lower temperature than the other one. And this is the surface temperature of the solar cell. We have recorded the voltage value for the same, for two solar cell, with the one with phase change material and the one without phase change material, and there is a clear difference in both the voltages. You can see from this photo. Finally, we calculated the power output, and it is shown here in this figure, power versus time. And here also clearly it can be seen that there is a difference between the two solar cells, the one which we are using with phase change material and the another one without phase change material. Now the difference here is less, but we are proposing this process can be done properly, because the mechanism that we have developed, there were problems, manufacturing faults were there. So if we do this process properly, we can get more efficient result, and we can increase the efficiency further. To conclude my presentation, I will conclude with these points. The performance improvement of solar cell using cooling technique has been investigated in this research. One cell was continuously cooled using phase change material, which was paraffin wax, and the second one was left without cooling. It has been observed that the performance of the photovoltaic module or the solar cell can be increased using phase change material for cooling purposes. And a maximum improvement of around 2% and a maximum reduction in temperature of about 12.3% were achieved with the proposed cooling mechanism. As a future work, the following can be done to enhance the reliability of the experiments and check the experiments further. These two things can be done. A fan can be used to mimic the air cooling of the solar cell, because we have not used the fan to mimic the wind or the air on the solar cell. And the experiments can be conducted in the real environment, like outside, to see and confirm the recharging of the phase change material, like if it cooled down in the night and then it becomes solid or not, like if it will melt in the daytime, it will melt, and then we have to see that the next morning it is again a solid material or not. So the experiment should repeat itself. That can be done as a future work. So that's it from my presentation. Now if you have any question, you are most welcome.